Hi, in this video we are going to implement the iterative deepening depth-first search algorithm. So let's get started. I'm going to create a new Java project, iterative deepening depth-first search ID DFS. Okay, I'm going to create a package, app, whatever, and we are going to have three classes here. The first is going to be called node. And it's going to represent the node in our tree, for example. It's going to have a name, private string name. It's going to have an integer depth level, as we have talked earlier. We are going to detect the depth of our algorithm with the help of this variable. And of course, we have to have a adjacency list, as we have seen in the previous videos too. So adjacencies list, and I'm going to have a constructor. It's going to get a name, this.name equals to name, and instantiate the list. It's going to be an array list, as we have seen so far. I'm going to override the toString method, as we have seen earlier too. I'm going to return this.name. I'm going to have a public void add neighbor node this.adjacency list.add node. And I will have to generate getters and setters. I generate a get adjacency list, a getter and a setter for the depth level and for the name too. Control Shift F to auto format, and that's all about the node class. At least I think it is. I'm going to have another class called the algorithm itself. So I'm going to call it algorithm, and we will have a private node, target node. It's going to represent the node we are after. I mean, we are going to search for a given node in our graph, and this target node will be the node we are trying to find. And we will have a private boolean is found, or is target found. It's a boolean to detect whether we have found our target or not. In the constructor of this class, I'm going to get a node target node. This.target node equals to target node. Okay. And we have a public void run deepening search. It's going to, we are going to get a starting vertex or starting node. We will have a int the actual depth, and while the target is not found, we keep running our algorithm. We're going to enter a break line here, line break, and DFS, because we heavily rely on the depth-first search, as we have seen in the theoretical video, that we are going to make depth-first search, but we have to terminate this depth-first search at a given level, and this is why we have a depth. So we have a start node and we have the depth, and on each iteration we keep incrementing the depth. We keep deeper and deeper in our tree. Okay. DFS. We are going to use a stack. We could use recursion, but in this iterative deepening depth-first search, it's much more easier to to understand with the help of stacks and not using recursion. Okay, so I'm going to use stacks with the node stack new stack. Okay, I'm going to have the start node dot set depth level. It's going to be 0 because it is the first element, and I stack dot push this start node. Okay, so as we have seen earlier, we just have to do a while loop. While the stack is not empty, we keep running our algorithm, and we just have to pop an actual node equals to stack.pop. I'm going to print it to the console. Okay, I have to check whether it is the node we are looking for. So if the actual node dot get name that equals to this dot target node dot get name, it means that this is the node we are looking for. So print out that node has been found dot dot dot. Okay, and this dot is target found equals to true. We have to set it to true in order to terminate this while cycle, and we just have to return, of course, and else if the actual node dot get depth is greater or equals to the depth, we just keep continue. And this is why that's the main difference between the iterative deepening depth first search and the normal depth first search, that we keep continue if the depth level are greater than the depth. So continue, and anyway we keep node actual node dot get adjacencies, and we keep incrementing the depth level. Actual vertex dot get depth level plus 1, of course. We keep incrementing it by 1, and we push it to the stack, the node. Okay, so okay, let me test our class. So I'm going to create an app. I'm going to I'm going to create a node 1 equals to new node, for example A. I'm going to have a node B, and C, for example 2 and 3. The node 1 dot add neighbor node 2, the node 2 dot add neighbor node 3. We are going to instantiate the algorithm itself. The target node is going to be the node 1 at start. I'm going to run with the start node. It's going to be the 1, 2. So we should get the first A. Node has been found. If we set the target node to B, which is node 2, we should get visiting the A and the B, of course, and we keep returning. If this node 3 is the one we want to visit, then we keep visiting the the AB, and the ABC. Maybe in order to be a bit more specific, I'm not going to put an end line, and maybe it's going to demonstrate a bit better that we are going from layer to layer. We are going to visit the first node, then the second node, and then the third node. So yeah, that's all about the deepening. That's all about the iterative deepening depth first search. For example, we say that the first is going to have the node, then yeah, A, and the A and the C, and the node has found we are looking for. So that's all about iterative deepening depth first search. Thanks for watching.